Hello everyone, this is Hatter, and this time I will explain how to install and run OpenStack on OpenShift. The background of this testing or the demo is that currently we are moving from the VM cloud to the container cloud, like moving from OpenStack to OpenShift. But during this movement, there are some status in the middle. Uh, how host OpenStack on the OpenShift, treating OpenShift as undercloud and OpenStack as OpenCloud. Overcloud is one of the options. Today we will follow this scenario and install the OpenShift and then install the OpenStack on top of that in a home lab. This is the diagram of our deployment, and because it involves OpenStack and the network part is very complicated, and the diagram is very large and the display is small, and I will switch to a larger one, and we will speak it piece by piece. We have two bare metal hosts in our home lab. One is a helper node. On that, we will deploy some additional or service or some service on this node, like DNS, like container image registry, and like some web server host some static files like OS image, RPM repo, something like that. And there is another bare metal host is relatively large. It has 24 CPU core and over 100 gigabyte memory. And on that we will create several KVM. On that, three of them we will install as OpenShift using API full automation mode, and one additional we will add additional worker node to the API OpenShift cluster. And because we are using API install mode, so we need to provide them with Redfish or something like that through the Virtual BMC, and we will use some tools to simulate on the host. And there we have also need to create two bridges. We know that following the official document, they need two bridges. There are two methods to install using API mode. One method only need one bridge, and it's a bare metal bridge. But because we need to install OpenStack operator on the OpenShift from the official document, we need another method to do with the API mode installation of OpenShift. That is, we need additional provisioning bridge. And the network part is very complex, and there are so many bridges and so many links and so many VLANs networks, and that is because OpenStack need a separate network plan. And their special one is that we need to create a KVM inside of one of the master node of OpenShift. That means we need a nested KVM inside another KVM. This is a special one, and we will use the nested KVM as a controller, and use the additional worker node as the computer node. This is the whole diagram, and then we will talk step by step to see how to install this cluster and how to run the OpenStack. And the procedure related for is simple, and it's 5 steps. One step is to install the cluster using API mode, and we will choose the 3-node or compact cluster mode to install that. And then we will add additional worker node to the cluster, and we will install some operators with some operator to the OpenShift following the official document, that is CNV, that this will create KVM in the shift for us. And AM state, it will manage the NIC configurations. And SRV, it will provide the pass-through features to the KVM created in the OpenShift. And NFS, it will provide us some basic storage functions. And the next step is to install Openstack Operators. And then we make some more configurations following the official document, make the OpenStack parameters, and create the OpenStack Ansible playbooks, and deploy the OpenStack overcloud. And this is a totally 5 step. It sounds simple, right? But look at the directories of the menu. It's relatively complex, and we need to explain it little by little. First, we need to prepare the host. We will install our all 4 KVM on the single host, and the resource is limited. So we need to make some overcommit, enable the overcommit features. First, it's a memory overcommit, and do the things like this. And that means that we can create several KVM. The total memory will over the physical bare metal memory limit. And then we need to enable nested virtualization. That means we can create a nested KVM inside another KVM. And this is a feature of the Intel CPU, and we can enable that following these steps. After that, we need to configure the network. And following the official document of IPI installation mode, uh, they have provided the scripts that create the bare metal bridge without following the documents, and run the script and add other IP address that we needed. But for the provision network, the official document says that we need an additional hardware NIC to do that. But this time we will create a VHLAN and add the VHLAN interface to the bridge, and configure the bridge to the KVM. Then the KVM or libboard can use it. Following this, we only need 1 NIC, and we can provide two bridge network. This network part we will enhance that, because this is too simple, and we make so many VLANs in the one bridge, and they will overlap each other, and bring some error message to different VLANs. And later we can enhance that with SDN, controller. But now this is a home lab, and we can do the simple one following the configuration here, and then we can just continue our testing. And then we need to prepare the repo, because we will install OpenStack that needs to install some RPM on the host. And the base platform is OpenShift. OpenShift doesn't provide only it's based on CoreOS, and it runs software in container, the container, so they don't have the RPM repo. We need to find a real host and download and mirror the repos, and then download to our lab environment, because our lab environment is disconnected, and create a repo file, and this repo file will be used later to initialize or patch the OpenStack class nodes. And then we need to host a web service to provide this this repo to provide the access to this repo. And during this time, during these things, we have there's one tips because there is they need to use long-term support subscriptions. So we need to specific set the release to 8.6. Otherwise, you will not download this repo. It will report the 404 errors. And after we prepared the repo and we continue to do the story config. Before this, we configure the memory overcommit. This time we configure the story overcommit because each node will use we will provide each node with almost 4 disks, and one disk is over 500 gigabytes. But in fact, the lab will use very little storage. So we enable the same provision, and this will overcommit the storage, and the result is very good. And then we will define the KVM, set up KVM. First time is remove all the KVM definitions because we want to do this lab again and again, and so we provide a script that you can remove all the existed environment, and you give you back a fresh environment. And then we can define the KVM. First, we'll define the storage, and then we define the KVM in XML, and finally we define the KVM. Please note that we do not start the KVM because the installer will talk to the KVM through the Redfish directly and attach boot up images and then start up the KVM. We just define the sketch of the KVM. Then define master 1, master 2, master 3, and the worker node. After that, we will define the virtual BMC and provide the Redfish interface to our side. We download the Openstack subproject Sanshi and start out and define systemd service to auto start this Redfish to start the Redfish service. And then because the internal configuration needs some MAC information and Redfish instance ID, so we will use this script to get the MAC interface MAC address and get the Redfish instance ID from the host. Okay, then we finally go to how to define the configuration of our OpenShift for our OpenShift installer. First, find your version you want to install and get your binary to put your binary to the random path. And you also need to provide a web service to host some OpenShift install material like the Archer CoreOS images, something like that. And then you need to create the installer file. What I did is create additional users, additional user, and in the user space and in that user environment. We define some environment variable like NPT server address, VIP address, was the cluster domain name, and each node's IP, host name, interface, which disk to install, and the DNS gateway, something like that. And then we define the installer config yarn. This is a critical configuration files. During the files, we define 3 master and 0 workers. This is how we configure the compact server. And because we are API install mode and we define some parameters in the bare metal, the most important one is provision networks managed. This is required by the OpenStack operators and some base host image, and we will doing that in the static IP configurations. So we defined each node with static network configuration and the BMC access information. And this all three master defined as here. And we create the manifest and copy our additional configuration to the manifest path, like NTP address, NTP server address, and the local image registry address, because we are a disconnected environment. And we got the configurations, and we use a script to copy this manifest to the KM host. And we also need to copy additional binary to the KM host, because the API mode, bare metal mode installation, you use a separate installer, and we need that binary. And to this point, and we can just run the installer on the KM host, and we don't need to do anything else, just wait for the result. And after, because my environment is resource limited and it's not very quick, so it consume over 40 minutes to finish. And after finish, we will get a username and a password to log in the cluster. And we don't forget to copy back the login key back to the helper server, because we will continue to do operations on the helper. And after that, we can continue, but I prefer to do some additional configuration of the cluster, because this is home lab. What I prefer is to log in using root directly using password. And after login, we don't have some session timeout things to worry about. So I provide some script to configure the cluster, so that it's handy for your home lab for your testing. But remember, this is not recommended, or this is not good to run into production. And there's a tips that when you log in to using root on the master, and there's some additional config that you can run the OC command directly on the master. They will use the local API servers to do that. Okay, there's additional script tips that helps you power off the cluster, reboot the cluster, power on the cluster, something like that. You can use it as you want. Following the OpenStack deployment instructions, they need additional JIT service, because we are a disconnected environment. So we need to deploy a JIT in the ER environment. OpenStack installer will generate install Ansible Playbooks and upload to this JIT service, and then sync the JIT service, and then install the OpenStack cluster. And in the GTR, we need to configure SSH access, and we need to put the key here, the key inside GTR. Because what our configuration is not a standard SSH port, is another port other than 22, and the URL is different, and they will bring some small troubles to us later, but don't worry right now. Okay, and after that, we will add additional worker to our OpenShift cluster. Uh, uh, OpenShift will call the Redfish interface and boot the worker node using the CoreOS image. And after startup the CoreOS image, it will start the an ironic agent service. And if no additional configurations, the ironic agent service will check how many CPU, how many memory, how many disk on the host, and then report the host information to OpenShift, and then power off the workload. And later, we will provisioning the workload as OpenStack compute node. That means it will provisioning the workload as a real node. When OpenShift will boot the workload still using the CoreOS image, but the ironic agent service will do additional things that will write the real image to the workload disks and then reboot node, and then on that point the node will boot into a real a planned real. Yeah, this is what the other bare metal host works. And the configuration related simple, and you have to define a bare metal host that provides the BMC access information. And the most important thing is that you because we are the static IP address mode, so we need to provide the network information. And the official document of the OpenShift is have some bugs, and the configuration in the document is wrong. So just follow what I said right here, and provide the static network information, IP information. And then wait some moment, it will provision the node, and it's okay. After that, we will install the NFS service, and we chose the NFS service because it's simple, and for our home lab, it's okay. And we will need to provide a local volume to as a backend storage of our NFS service, and we define the choose a node, and find host path as the backend as the local volume, and then we install and deploy the NFS service based on the local volume, and we provide some script and to define your parameters here. And to this point, the NFS service is okay. Then we install the operators that describes on the Openstack document. And this operator will just following the official directory, and we also put the command line here. Just do it one by one. And the pattern is that we install the operators using the automatically approve mode. After install the operator, we will manually set the install approval mode to the manual. That is because this lab environment, we don't want our environment to be broken for the automatic operator upgrade. So we just set the install approve to the manual. If in the production system, we also recommend that the install plan mode, approve mode set to manual. All these three operator just follow the same way. Then we will begin our OpenStack installations. First, we will install the OpenStack operators. Because this is a TP version of the software, so they have some strange things. First, that we need to build the catalog by yourself, and you have to check the Red Hat website to find which what's the latest version of the OpenShift operator bundle, and build the catalog service by yourself, and then you define the catalog source with your build image, and then you define the subscriptions. And to now, you got working OpenStack operator, and then we will begin to deploy the OpenStack. The first thing is to upload a real image, because our OpenStack is based on some real version, and we need to download the real image and do some configurations on the image. They are all about how the nickname, how the nickname is generated, and then using the official CNV command line to upload this image. After that, when doing upload, you have to wait sometimes because first it will upload the image and then it will convert the image on inside the cluster. So it will consume small time. And then you upload your SS key to the cluster and define the default password for your OpenStack node. And then there's some important things that you have to define the OpenStack network parameters. We following our network diagram. We will define two bridges. Each bridge will define several networks. Each has different VLAN numbers. And this is what we define here. And the definition is relatively simple. We have defined two bridges, each bridge attached to the NIC. There are some tips here because in the official document, the bridge name has some conflict with OpenShift, so you have to choose another one. And then you define several networks. Each network will attach to one of the bridges, and you give each network some IP address so the address can attach to the VM. After that, it will call the nm state function of the OpenShift. That is the NCP CR, and then it will help you to configure each node's network. Then we can deploy the next KVM as a controller, and we need to define a virtual machine, and we will only define one controller, and which with many networks. And we define another pod. This pod will have OpenStack client binary inside that, and we will bring it several network to attach to the pod. After define that, we just wait a moment to wait some time for the controller to start up. And after startup, we can see that we got a virtual machine inside the OpenShift, and it's just a blank real. We don't have anything installed on that node. And after that, we can prepare the OpenStack installer Ansible script. And the official document is very good here. It provides us a sample, but the sample has some bugs because they didn't define the storage management network, and so we just add here. After that, we go into the network client pod and to generate a template and copy out. And then we upload all of this configuration to the OpenShift. Then we define some additional parameters and then upload to the OpenShift either. Till now, we will continue to deploy our compute node. You have to this point we just power off this compute node and write the real to the disk and reboot the node, and the node is a empty real node. What we did is define OpenStack bare metal set and define some network it had to attach and define that the base image it will use. And with sometimes it will have when we call the OpenShift bare metal 3 interface, and we can see that the work node is provisioned and the consumer is different. It's computer HCI, and we can see the result here. To this point, if we are connected cluster, we can run the Ansible playbook now. But we are disconnected environment, so we need to patch for the OpenStack node to to let the node to use the disconnect RPM repo source for to use the local container image source. That so we define some parameters. We use Ansible and use the smart inventory and to run the command on each node. And after that, we need to generate our answer books. We just define CR and wait. But here is the JIT access GUI bugs here because where UI is different. The port number is different. The script in the Ansible playbook generator will not recognize our SLI. So the SS configuration is wrong. We need to add our configurations manually, and then it will continue generate the Ansible playbooks and run successful. After that, we can run the Ansible playbooks. We log in into the OpenShift client, and we patch the SS configuration files, and then we sync with the Git repo, and then we copy the deploy script out and patch the Ansible playbook with additional debug output. Then we run this Ansible deploy. It will deploy an overclock on the controller and on the computer node. Because we are necessary virtualization, the system is very slow and it will cost over 2 hours to deploy successful. After that, we can get access the OpenStack web console and using the password. After deployed, we can try it out. We can try to deploy VM on our OpenStack. What we did is that we create a library. We define we upload a disk image, and we create the image in the image in the OpenStack, and we make some security configurations, and we make some network configurations, and we define a floating IP, and we create the server and add the floating IP to that. After that, we can SSH into the VM created by the OpenStack. We can see that it has IP address from the tenant address space. And now this is we complete our deployed and try out. And additional things that we will learn how the network is configured. So I put the network configurations of the computer node, the IP informations, the OS informations, configuration informations, and the OS flow dumps. Also, the controller's network information here that help us to learn, to analyze, to think about how this OpenStack is configured and run. Okay, this is all about how to run OpenStack on OpenShift, and hoping this is helpful. Thank you.